Hello, and welcome to another X-Pro tutorial for SolidWorks modeling. In this tutorial, we will be creating 3 models. First one will be kitchen sink, for which we will need a forming tool, which is this here. Actually, we will first create the model of the forming tool, and then later we will use it to create the kitchen sink. And after that, we will create this strainer. So let's begin by creating a new part. Let's go to New Part and say, OK, and as always, we will be using millimeters for drawing. Let's begin by creating the forming tool first. So I'll start by creating a sketch on the top plane. Right-click Sketch. And I will use a center rectangle. Let's start from the origin. And I'll say that this is 550. Press Tab. And again, 550, double-click the scroll button to view everything we drew. Immediately, SolidWorks added this equal relation here. Let me just hide the relations. We don't need to see them. I'll draw a circle in the middle of this line. This one will be 150 millimeters in diameter. And now let's trim using the power trim. I'll keep the entities as construction geometry. I'll just get away this axis here. Now I have to say that these two are equal to make the sketch fully defined. Let's just see what else we have to do. There we go. And I will add some sketch fillets. Here they are in the Sketch tab. Let's select Sketch Filled and say 50 millimeters in radius, so just say yes. And this dialog appears. Let's add the fillet in each corner. And for some reason, SolidWorks won't let me add a sketch fillet here. So never mind, I'll confirm this command. And then, again, select this corner and say yes and confirm it, and there we go. We have the desired sketch. It's fully defined, now we can extrude it, so here it says it's fully defined. Let's go to Features Extrude, and I'll say 7 millimeters and extrude this. Now we can make a sketch on this surface here, right-click Sketch. And I can say normal too. Again, I will use the center rectangle, which will be 570 by 570 millimeters. Now I can extrude this 20 millimeters. This is what we have so far. We can add fillets to these edges here in the Features tab, select Fillet, and let's make it 5 millimeters. First, I have to select this edge and then confirm it, and then choose the Fillet feature and select the other edge here, not the surface or edge. And there it is. Now we can make a sketch on this surface here, space, to look at normal to this surface, right-click Sketch. What I'll do is first draw a center line from here to this edge, and then use the center of this central line to create a center rectangle. And I'll add some smart dimensions from this edge to this line. Let's make it 25. And from this line to this edge, also 25. Now it's fully defined. I will just add some sketch fillets, which will be also 50 millimeters in radius. Let's select these edges here. Right-click to confirm, and once more confirm. There we go. We have a fully defined sketch, and now we can extrude it. Let's go to Features Extruded Boss, and I'll say 100 millimeters. But what I will do is to add a draft in words and save, say, 5 degrees. So I don't want to a draft outwards, I want it inwards. Okay, let's add some fillets. I'll add a 50 millimeter in radius fillet to this edge here. I will add another one, only this one will be 10 millimeters. Sorry, not the surface. We'll select the edge and then confirm this. Good. Now we will make a sketch on this surface here. Let's just say normal, right-click and say Sketch. Again, I will draw a center line from this point to this point here, and I will draw a circle in the middle of this central line, which will be 70 millimeters in diameter. Then I will extrude these 8 millimeters in depth and say, okay, we can add some fillets to these edges. Also, let's make these 3, for example, this one and this edge here. Good. And now you will see later why. But I need a surface here, which is a bit smaller than this circle. Here, what I'll do is make a sketch on this surface, and I'll simply offset this circle. In words, let's say reverse. Let's make this 7 millimeters, for example. Confirm the command by using split line function, which is here in the Futures tab curves. We have split line. It has selected the sketch already. What I want to do is simply create a surface inside of this circle here. On this same surface, I want a smaller surface. I just select this one and say, now, as you see, I have this surface. And this surface here also. Good. Next thing we have to do is make this part become a forming tool. And the way you do this is by going to Sheet Metal tab. And here we can select the forming tool for stopping face. So the face at which the price will stop. We will select this face here. So this will be the end, or actually as it's called the stopping phase for phases to remove. I want this surface we just created using the split line function. We have to add an insertion point. We will select the origin. Okay. There we go. Now you see, the part has changed color. It has this red here and the yellow color. And this is some green or blue. This is now a forming tool. It's not a standard part. There is just one more step that we have to do to make this forming full, usable. Let's save it as a forming tool. Let's go to Save. As here, I will choose Form Tool. So SolidWorks will take me to the design library, the default path. Here we have forming tools. I already saved mine. It's called Sync 1, so I won't save this part. You just name yours as you wish and save it again where you want. I would recommend this path. You can create a new folder here, however you want. And I will simply close this window because I already made the forming tool for myself. Now, since we have the forming tool, we can create the sync. So what I'll do is go to New Part, press again, millimeters. We can begin by creating a sketch on the top plane, right-click Sketch. And let's make a center rectangle, which is 600 by 600 millimeters. Double-click the scroll button to make everything visible. And now, instead of going to Features, Extrude Boss, what I'll do is go to Sheet Metal and use this Base Flange tab feature. When I notice that in the design tree, we only have these three planes and the origin and this sketch we are currently in. So what will happen when we create this feature? We will have a new, let's say, folder or an icon here saying that we are now in sheet metal mode. Let's go to Base Flange tab. Let's make the plate 1.5 millimeters thick. The K factor is 0.54 sheets, a metal. And we will keep the outer relief on 0.5. When we look at it from the side, you can see that the material is going downwards. If we click here, reverse the direction, it will go upwards, but it doesn't matter for us. Let's confirm this. And here you see, we have this folder called Sheet Metal, this suppressed flat pattern folder. Now we have the base. We can now make the edges. I'll look at the part from this side here and make a sketch on this surface, right-click Sketch. I'll simply use a line tool. Let's go downwards, 20 millimeters, to the right 10, and up 5. And you can see how fast we made this a sketch and all that is fully defined. Since we are entering the dimensions as we sketch, we have this sketch now to create the edges. I will use a tool called Miter Flange. Here it is in the Sheet Metal tab. Let's activate the command and immediately select it at this edge, which is a normal to the sketch we created. I want it on all four sides. Let's select this edge here. Let's see if the diameter or if the radius of the band is okay for us, 3 millimeters. Here we can change the flange position if you want. But for me, this looks okay. Let's confirm the command. Now we can use the forming tool to add depth and to this part and make it look like a kitchen sink. So what we'll do is go to Design Library. Here, Design Library. And we can find Forming Tools. This is the one I made. You will find yours if you say that to this path or this folder. How we can activate it simply by dragging it over to this surface where we want the forming tool to do its thing. Let's release it. Let's look at it normal to the surface. If you want, you can rotate the part here. I will say 180 degrees. And the placement phase is this surface. This is what we wanted. Now let's go to Position tab and simply we have to find some point for us too. Connect this to, for example, we can show this sketch. Or let's try and find the origin point. Sorry, let's do this again. So what I'll do is show this sketch normal too. And then drag the forming tool to the surface. Again, I'll rotate it 180 position. Then I will drag this to the origin point. And now this looks good. It's centered to the kitchen sink. And let's just confirm this and see what happens. There it is. We can hide this sketch, and we have converted this metal plate using the forming tool to look like a kitchen sink. As you can see, if you remember, when I go to the forming tool, this red surface here, we said that it will be a phase to remove. And this is exactly what SolidWorks did. It removed this part of the sheet metal plate. We can add a hole for the tap so that we can cut it. Let's create a sketch on this surface here. We can use a circle tool. Let's make it 40 millimeters in diameter. We can see that it is horizontal to this origin point. And let's add one more dimension to make this fully defined from the origin point. For example, 250. Since we are in sheet metal mode, we don't have to say how deep we want the cut to be. You can simply go to Sheet Metal tab and say Extrude Cut and link this to the thickness. This is 1.5 millimeters. We know this, but we don't have to think about it since SolidWorks does it for us. And there we go. Now we have a hole for the tap. The last thing we can do is save this part. We go to Desktop and say Sync. If you want, you can add material. For example, let's go to Edit Material and say Stainless Steel. Here we have some sort of stainless steel sheet, and let's say Apply. And now you can see that it has changed color. Now that we are finished creating the sink, we can go and create the strainer. We will only make this part so that we can show how some other sheet metal features in SolidWorks work, such as jog and sketched bend. And we will also see how fold and unfold work. So to create this strainer, let's begin by creating a new part and say, okay, again, millimeters. We will start by creating a sketch on the top plane, so right-click, Sketch, and let's select the center rectangle. Let's make this line 145 millimeters by 165. Again, instead of going to Features Extrude Boss, we want this to be Sheet Metal. Let's go to Sheet Metal tab and say Base Flange tab. Let's keep the same parameters as we did for the sink. Again, we can add some material. Let's again say Stainless Steel Sheet and let's say Apply. And now what I want to do is bend this area here so that it looks like a letter S. The way I can do it is by using jog function here. What it requires is a sketch actually online. Let's create a sketch on this surface here. Right-click Sketch, let's say Normal too. I'll simply draw a line from this edge to this one here, make sure it's vertical. And then I will add dimension, let's say, from the origin to the line 45 millimeters. Now I can exit the sketch. And let's go to Sheet Metal tab and select Jog. The function will ask us which line we want for bending. And it's going to ask us which one of these faces is the fixed one. We want this surface here as the fixed phase. The height, you can choose the height of the band. So outside, offset, inside, or the total or overall dimensions from the top to the bottom. I'm going to select this here and make this 24.41. Here you can change the angle of the jog 45. You can see what it's going on. What's happening if I change the angle, let's say 60 or maybe 70, but for me, I think 55 will do. You can see what this function does is actually paint this plate where we drew that line and then creates this S-shape bend. Let's confirm command. This looks quite good. Next, I want to bend this side here using the sketched bend. So it also requires a line that's created here on this surface. So right-click, Sketch, and look normal too. I'll draw a line from this edge to this edge here. Let's say from this edge, I will do this again. Let's make these 20 millimeters and exit the sketch. I will bend this part from the line to this edge upwards or downwards. However I want it automatically entered the jog function, but I don't want this. Let's go Sheet Metal tab and select Sketch Band for bend parameters. Here it is asking us which is the fixed face. This is the face we want. I can choose under which angle this will be bent. I want it under 90 degrees. So the difference is that this makes a simple bent, right where the line is, but jog makes this S letter S shape. Let's make these 90 degrees and use the default radius. Here, 3 millimeters. Let's confirm this. And this looks very good. I just extend this way. We will use an already familiar feature called Edge Flange. We used it in some previous tutorials. And let's make this 15 millimeters, for example. Now we want to cut some poles here where the warm water can drain, so I'll create a sketch on this surface. Look normal too. And let's make a center line from the center of this line to this line here. And I'll start by creating center point slot, right in the middle of this line. Let's make it 80 millimeters long and 3 millimeters wide. Now instead of drawing 15, 20 of these slots, I'll simply use linear sketch pattern. You can see here that we don't want anything along the x-axis. We only want it along y-axis, since this is what's made as an option here, or I can choose an edge for myself, but I don't want to do that. Let's change this to 1. This means that no pattern it will happen in the x-axis direction. We want 8 along the y-axis, and for entities to pattern, simply select this point here. You can see that it has selected the slot. And let's make the distance between slots 9.5. Good. You can see that now I can still move the slots. This is because we have to enter a value here between each one of these or between this one and this one. It doesn't matter this one and this one, you just have to add one dimension here. This one, I want this to be 9.5, and you can see that everything now is fully defined. But we want the slots this way. Let's again enter the sketch pattern along x-axis, and we don't want the pattern 8. Let's reverse direction, and that is the pattern, this slot. Again, 9.5. And let's confirm this. Once more, I will add a dimension, saying that this is 19, and you can see that, again, it's fully defined. We can cut this. Let's go to sheet metal extruded cuts, and again, simply say it linked to thickness and confirm this. These edges are sharp. This is not that good. So since we don't want anyone to hurt their hands, we can avoid this by adding hemp. Let's go here, select a closed one. Let's make it 5 millimeters and simply select these two edges here. And this way, we'll avoid somebody getting hurt. Now we can see how fold and unfold functions work similar to flatten. If you click here, flattened will show us the flat pattern of this part. Similar to that, the unfold function works here in the sheet metal tab. You can find it unfold. Let's select it. It is asking us which one will be the fixed phase and which bends we want to unfold. For example, I want this surface here to be the fixed phase, and I can choose by hand which one of these bands I want unfolded, or I can say, collect old bands and then select from them. But let's say I want all of them unfolded. Let's confirm the command. And now you see, we have basically the flat pattern because I selected all the edges, but it's not the same as flattened because it is not showing us where the band lines are. The reverse function from unfold is the fold. Again, we can select this face and collect all the bends. It will collect them by default. Let's bring the part back to its original state. Basically, this is how it works. It's helpful when you want to unfold just some parts of this entire model, and you can then create some cuts or do wherever is required. Let's again check the flat pattern. Now you can see the difference. We have only these lines that are actually where the press has to hit the plate for us to have this as an end product. And we're finished. Thank you for watching our tutorials. I hope you like them, and I hope I see you in the next one.